Okay, well, let's get started. You're in the Future Technologies Initiative workshop on the use of photonics for computer interconnects. My name is Mike Bortz, and I put this workshop together. I've been involved with OCP for about 5 years. OCP came to me a year ago, and they asked me to think about a workshop and an initiative within the Future Technologies organization that was forward-looking, where the use cases and the deployment scenarios were 3 to 5 years out at a minimum. Now, we all know that optics comes into this community through scale-out and through networking and through Ethernet, and those are fairly mature applications. People know how to build fabrics using Ethernet transceivers. That doesn't mean there's not a lot of work going on with Ethernet networking and fabrics. We heard about that this morning. But those are not applications that are 3 to 5 years out or more. Those are things that are needed today and next year. So I decided it might be interesting to look at short-reach in-server interconnects and try to understand better about how photonics can displace copper over the longer term. So these are short-reach interconnects up to maybe 10 meters using photonics, where the real application is scale-up, not scale-out. Now, there's many different use cases, and there's a lot of confusion about the different kinds of requirements. There's server disaggregation, there's resource composability, there's processor-processor interconnects, cache-coherent interconnects. The big one is the memory interconnect to deal with the memory wall problem, and memory disaggregation and pooling. These applications all require photonics in the long term. And then more practically, there's how to carry CXL over PCIe over optical. And there's other talks on similar concepts at this conference. So that's kind of what we're going to talk about today for the next couple of hours. But what is a workshop? Well, the idea here is eventually to get to a formal OCP project. That's going to take some time. So today, we're here to have a workshop, build the community, and listen to what people have to say. The idea is to write a white paper and publish it by the end of this year. We have a draft, but it needs a little bit of work. And then in 2024, hopefully we'll have a Workstream, which is sort of an informal OCP project where we have weekly or bi-weekly meetings and coalesce around a set of use cases staged by interception point for when photonics can displace copper in that use case. And if we make good progress, maybe in a year or two, maybe at next OCP or in 2 years, we'll incubate or launch a formal OCP project. So it gives us plenty of time to have strategic alignment with other things going on at OCP and in the broader community. So just some pictures about use cases. We've seen a lot of this already at this conference. The picture on the left is just a block diagram of a 2-socket server. You can see all kinds of interconnects. The big blue line in the middle is the cache-coherent interconnect between the CPUs, or it could be between accelerators. The green things on the far left and right are banks of DDR memory. So there's a memory interconnect that's constrained by pin-out problems in most applications. That's why people go to HBM co-packaged memory. The pink lines are PCIe. So a lot of interconnects inside servers, a lot of applications in the long run for optics. The memory hierarchy is shown on the right. You guys have all seen this diagram before. We're not talking about photonics changing the cache. We're not talking about photonics changing storage on the bottom that's already disaggregated. But in the middle, with the main memory and the CXL memory, that's the sweet spot for photonics. Latencies of a couple hundred nanoseconds, and memory appliances that might be in the rack or disaggregated to a separate rack. And RAM from Microsoft and Nathan Tracy at the session this morning on optics really touched on a lot of these things already. Now, there's many technologies and architecture options for these use cases and applications. In terms of platforms, there's a variety of silicon photonics platforms people are developing. There are VCSEL platforms, there are LED platforms, there's WDM and comb lasers. Some people study and are working on optical PCBs. There's a lot of variability in the capabilities of these platforms. Some people talk about 2 gigabits per second per lane, and other people talk about a couple of 100 gigabits per second per lane, so a factor of 100 in per lane speed. A lot of variability with the architectures. There's a range of pluggables to LPO, to NPO, to CPO, with the evolution of ecosystem problems. There's retime solutions, unretime solutions, DSP-based solutions, solutions with no DSP, questions about clock forwarding. So a lot of architectural questions will have to be answered to push optics into some of these interconnect applications. Some people even talk about optical switching embedded in the PCB. And then for the people that are driving this from a use case and an application perspective, there's requirements. The requirements vary. The kinds of requirements we're worried about is reach, native bit error rate, whether or not FEC can be used, the latency requirements that are necessary, power, of course, and reliability, which is something else that's been touched on already at this conference, that optics does not have adequate reliability for certain classes of high-volume applications. And then that bottom one is critical cost. Optics is anywhere from 10 to 30x too expensive today. I won't go through this table in detail, but what you'll see from the presenters today is that they have some tables in their presentations. And I've asked everybody to work on these tables to get some sort of a methodical way of dealing with things. So there's one table on elucidating the requirements for applications and use cases. That's here. So talk about the use case, talk about the links per host, the host interface, things like that. And then for the technology providers, there's a capability-based table. What can this technology really achieve in terms of, data rate, density, power, picojoules per bit, latency, whatever it is. So you'll see a bunch of tables like this. In the long time, we'd love to get these really filled out and agreed upon. That would be part of the future activity. So we have an agenda for today which goes all afternoon. We have a session that goes till about 2:15, which is application and use case presentations from a number of people. And that session ends with Bob Wheeler from Light Counting talking to us a little bit about the market. And then we'll take a break. The break may or may not overlap with the coffee outside. I'm not sure about that. Then we come back and we have the technology sessions where people will, from different companies that are technology providers, will explain to us how they can they can achieve some of these application requirements. Now, at the end, we'll have a panel. And originally, we were going to have a break and then come back and have like a panel and an open session. But I don't think we should take a break and then come back because there's a party with booze at 5 o'clock. So I think what we'll do is we'll end, and then I'm going to ask the presenters to come up and say a few words about things that they think are really important for the purposes of the white paper and the Workstream in 2024, things that are on their hot button. Could be technical requirements, could be business requirements, and then the audience can also tell us things that they think we should be focused on in the next year. So with that, I would like to introduce our first speaker, and that is David Peeler from Dell.